Let's start. Second concept of this chapter, relationship between zeros and the coefficients of a polynomial. Consider a polynomial p of x. Let us consider a quadratic polynomial ax square plus bx plus c. A, b, c are the coefficients of p of x. Let alpha and beta be the zeros of the polynomial p of x. Then there is a relation between alpha, beta and the coefficients a, b, c. Now what is the relation? Sum of zeros means alpha plus beta. The value of alpha plus beta will be always minus b upon a, means you can say minus of coefficient of x upon coefficient of x square. Also we have product of zeros means alpha into beta. It will be always c by a, means you can say constant term upon coefficient of x square. So from now we'll denote the sum of zeros by s and product of zeros by p. Let's solve examples. Exercise 2.2, question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So here we have to first find the zeros of quadratic polynomial. This you have already studied in previous class, how to factorize a quadratic polynomial. First example, we have p of x as x square minus 2x minus 8. Recall how you split. We split in such a way that the product of the two numbers is constant and the sum, it should be the middle term. So we can factorize this as x square minus 4x plus 2x minus 8. From first two terms, you can take x common. So it is x minus 4. From the remaining two terms, take 2 common. So again it gives same bracket x minus 4. That is x minus 4 into x plus 2. The zeros of polynomial p of x are x minus 4 into x plus 2 equals to 0. That is x equals to 4 and x equals to minus 2. Let this be alpha and beta. So let alpha equals to 4 and beta equals to minus 2. Now the next is to verify the relationship between the zeros and coefficients. Here the coefficients a, b, c from given p of x. A is 1, b is minus 2 and c is minus 8. First is to find the sum. So sum of zeros means alpha plus beta is 4 minus 2. Also we'll find coefficient of x upon coefficient of x square, means coefficient of x is b, coefficient of x square is a, which gives minus 2. Now here alpha plus beta is 2. So you can check that the sum of zeros is minus of coefficient of x upon coefficient of x square. So sum is verified. Now the product. Product is alpha into beta. You can check in this way also. The product is constant term upon coefficient of x square equals to alpha into beta. Constant term means c, which is minus 8. Coefficient of x square is 1. In the RHS, alpha is 4, beta is minus 2. So we are getting minus 8 equals to minus 8, which is true. So product is also verified. So in this way, we can verify the relationship between the zeros and the coefficient. Let's solve second example. Let p of x equals to 4s square minus 4s plus 1. Here variable is s. So here coefficients are 4, minus 4 and 1. Let's factorize it. P of s equals to 4s square minus 4s plus 1. Now, what are the factors of 4? Minus 2 minus 2. So, minus 2s plus 1. From first two terms, you can take 2s common, 2s minus 1. From last two terms, minus 1 common, which gives 2s minus 1. That is 2s minus 1 into 2s minus 1. The polynomial will have zeros when p of s is 0. Therefore, 2s minus 1 into 2s minus 1 equals to 0. So 2s minus 1 equals to 0. Again 2s minus 1 equals to 0. Both gives same value, 1 by 2, 1 by 2. So these are the zeros of polynomial. Let us denote them by alpha and beta. Now verification. First is to verify the sum. Sum is minus of coefficient of x upon coefficient of x square. That is alpha plus beta equals to minus b upon a. Substitute the values of alpha, beta, 1 by 2, 1 by 2. Now from the coefficients, what is the value of b? It is minus 4 and the value of a is 4. So it is minus 4 upon 4. LHS is equals to RHS. So sum is verified. Now find the product. So product is always constant term upon coefficient of x square. That is alpha into beta is c by a. Alpha is 1 by 2, beta is also 1 by 2. From the given, we have c equals to 1 and a is 4. So both LHS and RHS are same. Hence, product is also verified. It's very simple. Let's try one more example. Here in third, you have to first rearrange the terms. 7x is to be taken in the middle. Third, let P of x, it will be 6x square minus 7x minus 3. Factors of 18, yes, 9 and 2. So 6x square minus 9x plus 2x minus 3. From first two terms, you can take 3x common, that is 2x minus 3 plus 1 into bracket 2x minus 3, that is 2x minus 3 into 3x plus 1. This polynomial P of x will have zeros if P of x equals to 0. That is 2x minus 3 into 3x plus 1 equals to 0. That is 2x minus 3 equals to 0 and 3x plus 1 equals to 0. That is x equals to 3 by 2 and the second value is minus 1 by 3. Let us denote these terms by alpha and beta. So alpha is 3 by 2 and beta is minus 1 by 3. Next is verification. Let's verify first sum. Sum is minus of coefficient of x upon coefficient of x square. So alpha plus beta is minus b upon a. Alpha is 3 by 2 whereas beta is minus 1 by 3. From the given polynomial, b is minus 7 and a is 6. So to the left side you take LCM. So it is 9 minus 2, 7 by 6. So LHS is same as RHS. So sum is verified. Now let us verify the product. Product is given by constant term upon coefficient of x square. Alpha into beta is c by a. Alpha is 3 by 2. Beta is minus 1 by 3. Now from given polynomial, constant term is minus 3. Coefficient of x square is 6. So here again LHS equals to RHS. So product is also verified. Next example is let P of u equals to 4u square plus 8u. Here a is 4, b is 8 and no constant term. So c is 0. First factorize the given polynomial. 4u square plus 8u. You can take 4u common, u plus 2. This polynomial will have zeros if P of u equals to 0. So 4u into u plus 2 equals to 0. From this we have two values, u equal to 0 and u equal to minus 2. Let us denote them by alpha and beta. Beta is minus 2. Next part is of verification. First, let us verify sum. Sum is minus of coefficient of x upon coefficient of means coefficient of u upon coefficient of u square. So alpha plus beta is minus b by a. Alpha is 0, beta is minus 2. From ABCs, we have b to be 8 and a to be 4. So minus 2 equals to minus 2. It means sum is verified. Now verify product. Product, it is constant term upon coefficient of u square, that is alpha into beta, is c by a. Alpha is 0 and beta is minus 2. Constant term is 0 and a is 4. So here again LHS is same as RHS. So product is also verified. So in this way you can solve the remaining 2 bits of this first question. So this completes first question of exercise 2.2. Now question number 2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. See, whenever we want to find a polynomial p of x from the sum and the zeros, apply this formula. P of x is k into x square minus sum of zeros into x plus product of zeros. In the first example, it is given that sum is 1 by 4 and product is minus 1. So required polynomial p of x is k into x square minus sx plus product p. So p of x is k into x square minus value of s is 1 by 4 and p it is minus 1. That is k into, you can take LCM 4. So it is now 4x square minus x minus 4. Now what is this k? This k is any real number. So for calculation, we may take the value of k to be 4 so that it cancels with denominator. And so we get a polynomial 4x square minus x minus 4. So this is the required polynomial. Let's see second example. In second, the sum is given to be root 2 and product as 1 by 3. So required polynomial p of x is k into x square minus sx plus p. That is p of x equals to k into x square minus root 2x plus 1 by 3. Take LCM 3. So this gives 3x square minus 3 root 2x plus 1. Choose a suitable value of k. So here we'll choose k as 3. So 3x square minus 3 root 2x plus 1 upon 3. So that 3 gets cancelled and we get a polynomial 3x square minus 3 root 2x plus 1. Let's see example number 3 in which sum is 0 and product is root 5. So required polynomial is k into x square minus sum of zeros into x plus product of zeros. That is k into x square minus 0x plus root 5. To choose a suitable value of k, let us consider it as 1. So it is x square plus root 5. So required polynomial p of x is x square plus root 5. So in this way, you can solve the remaining examples of this question number 2. So this completes exercise 2.2.